Today we're looking at polar form and how it relates to complex numbers. So we're going to learn how to convert between standard complex numbers and polar form. And we're also going to learn how to multiply and divide complex numbers that are in polar form. So to review, your polar coordinate or your polar form is r and then theta. So that's the point. The polar coordinate is r comma theta. And what that is that r is the distance from the pole, or what we know as the vertex. So that's the distance from the pole, or your radius. And that theta stands for the angle from the axis to the terminal ray. Okay, so r and theta come from the polar graph, and then they're going to relate to complex numbers as the modulus and the argument. So whenever we were calculating modulus in the complex numbers, we were calculating r in the polar coordinates. Whenever you calculate an argument in the complex numbers, you are actually you're calculating theta in the polar system. So to convert between complex numbers in the rectangular form to polar form and back again, so to go back and forth, just remember that r is equal to the square root of a squared plus b squared, and that a and b come from the a and b and the a plus bi. And then theta is equal to the tan inverse of b over a. Again, b and a are the real part and the imaginary part in the a plus bi. And then also you have a is equal to r times cosine theta, and b is equal to r times sine theta. So whenever you substitute a equals r cosine theta and b equals r sine theta into your standard form, you get r cosine theta plus r sine theta times I. Well, you can factor out the r, and then you get r cosine theta plus sine theta times I. So that's going to be the polar form of your complex number. So here's a plus bi, and then you substitute r cosine theta for a, and then r sine theta for b, and then factor out your r, and then cosine theta plus I sine theta. Because we use that so often, we're going to abbreviate that. So anytime you have cosine theta plus I sine theta and you've already factored out the r, you can abbreviate it as r cis theta. And this can go back and forth, so you just need to remember that it can go back and forth. Alright, let's do an example. We want to change 2 plus 2 square roots of 3i to polar form. So right now it's a complex number. So the first thing we want to do is we want to find r. So to find r, we use the formula of the square root of a squared plus b squared. So remember, a is 2 and b is 2 square roots of 3. So 2 squared is 4, and then 2 square roots of 3 squared is 12, because 2 squared is 4, and then the square root of 3 squared is 3, and then 4 times 3 gives us 12. So now we have r is equal to the square root of 4 plus 12. Well, 4 plus 12 is 16, and so the square root of 16 is 4. So now we have our r, and now all we need to figure out is our theta. Okay, so to find theta, we use this formula. Theta is equal to the tan inverse b over a. Well, our b was 2 square roots of 3, and our a was 2. And so now we need the tan inverse of 2 square roots of 3 over 2, which is actually the square root of 3. So we're looking for tan of what angle is the square root of 3. So on your chart, you should see that tangent of pi over 3 is the square root of 3. So that means theta is pi over 3. And just so you know, whenever we're dealing with complex and polar form, we want to stay in radians. We don't want to deal with degrees. So now we know that theta is pi over 3. Pi over 3 is in quadrant 1, which makes sense because this complex number, 2 plus 2 square roots of 3, is in quadrant 1. So make sure that your angle matches the number, and it does. So now we can write in polar form. So polar form is r cis theta. Well, we figured out r was 4, and then cis, and then we figured out theta was pi over 3. So this is a polar form of our complex number. All right, next example. We want to change 1/2 cosine pi over 6 plus I sine pi over 6. We want to change that to a complex number. So the first thing we do is we're going to go ahead and distribute this 1/2. So when we distribute the 1/2, we get 1/2 cosine pi over 6 plus 1/2 I sine pi over 6. Then we determine sine and cosine. We're in quadrant 1, so cosine of pi over 6 is the square root of 3 over 2, and then sine pi over 6 is 1/2. So you can use your chart for that. So then we just simplify and write in standard form. So 1/2 times the square root of 3 over 2 is the square root of 3 over 4. And then 1/2 times 1/2 is 1/4. And then we have the I. All right, so let's change 3 size 3 pi over 4 to rectangular form. So the first thing that we have to do is we have to change this abbreviated form to the full form, and then we also have to distribute our r, which is our 3. So we get 3 cosine 3 pi over 4 plus 3 times I sine 3 pi over 4. So remember, size means cosine plus sine. Okay, so now we look at our angle. Our angle is 3 pi over 4, and that means that it's in the second quadrant, which means that our values, whenever we determine them, cosine is negative because we're in the second quadrant, and x is negative in the second quadrant. And then sine is going to be positive because in the second quadrant, your y is positive, and sine has to deal with y. Okay, so now we get 3, and then the cosine of 3 pi over 4 is negative square root of 2 over 2, plus 3 times the sine of 3 pi over 4 is the square root of 2 over 2. And then we have our I. So then we simplify. 3 times negative square root of 2 over 2 is negative 3 square roots of 2 over 2. And then plus 3 times the square root of 2 over 2 is just 3 square roots of 2. 3 square roots of 2 over 2, I. All right, next example, we want to change -1 minus 4i to polar form. So the first thing we do is we find r, which is the square root of a squared plus b squared. So our a is -1 and our b is -4. So -1 squared is 1, and then -4 squared is 16. And then 1 plus 16 is 17, which means our r is equal to the square root of 17. Now we find theta. So remember, theta is equal to the tan inverse b over a. So our b is -4 and our a is -1. So we're looking for the tan inverse of -4 over -1, or the tan inverse of 4. So that's not going to be on your sheet of common angles, which means that we can go ahead and use our calculator. We'll do tan inverse 4, and if you're in radians, which you should be, you should get 1.333. And so we have to think about what quadrant we're supposed to be in. This complex number, -1, -4, that's in the third quadrant. So in order to be in the third quadrant, we have to make sure this angle is in the third quadrant. Well, 1.33, it is less than pi, which means it's less than 180. And then it's also less than pi over 2, which is 90, right? Because 3.14 divided by 2, let's say that's like 1.5. So it's actually in quadrant 1. 1.33 is in quadrant 1. So we need to go from quadrant 1 to quadrant 3. So we need to go like a whole pi over, right? So we're going to add pi to 1.33. So 1.33 plus pi gives us 4.47 as our angle. Now to write in polar form, remember polar form is r psi theta. Our r was the square root of 17, psi, and then our theta is 4.47. Alright, so there are two formulas that you can use to find the product and quotient of complex numbers. So here is the product formula. So whenever you're multiplying two polar form, all you have to do is multiply the r's together and add the thetas. If you are dividing, then you're going to write the r's as a quotient and you're going to subtract the thetas. So those are your two formulas. Let's see how these work. here we have 5 cosine pi over 4 plus I sine pi over 4. And we have 3 cosine pi over 6 plus I sine pi over 6. And we want to find the product and the quotient. So to find the product, remember we multiply the r's together. So our r's are 5 and 3. So we'll multiply 5 and 3 together. And then we'll add our thetas. So we're going to add pi over 4 and we're going to add pi over 6. So pi over 4 plus pi over 6 is 5 pi over 12. And then 5 times 3 is 15, which means our product is 15 size 5 pi over 12. Now to find our quotient, we put our r's over each other. So r1 was 5 and r2 was 3. So we get 5 over 3 size. And then we subtract our thetas. So we're going to do pi over 4 minus pi over 6. So pi over 4 minus pi over 6 is pi over 12. So that means that our quotient is 5 over 3 size pi over 12. All right, go ahead and try some problems on your own.